Something that I could do in no more than 2 minutes. I don't really know how that maps to your time scales, but I would hope if I could do it that quickly that... Oh, and without the aid of software, of course. Yeah.
Without software.
Yeah. But something I could do by hand that quickly.
Okay, so we can do it.
Yeah.
Really?
But when I get into exam mode, I can do an awful lot in 2 minutes. So. All right. Now, like example involving surface area. All right. So we have a cylinder, radius 3. Okay. So this x squared plus y squared is equal to 9. Then we have a plane cutting through the cylinder. So we have this cross section. So this is our surface S. Now, a plane has this equation, 2x plus 5y plus z is equal to 10. So what is the area of this portion? Now, the trouble is, we don't have x and y confined to a rectangle. We have x and y confined basically to this circle, x squared plus y squared is less than or equal to 9. So the best thing to do is to use polar coordinates for x and y, and then we'll leave z as is. So really we're going to use cylindrical coordinates. Of course, the appearance of a cylinder in a problem should tip you off to that. Right? Just like when you see a sphere mentioned in a problem, that should tip you off. Maybe spherical coordinates is a good idea. At least on an exam problem. Okay. So, now, what we'll do is we'll let u go between 0 and 3. So this plays a role of our r in polar coordinates. And then v will play a role of the angle, 0 and 2 pi. So now we have x is u cosine v, y is u sine v. So this is just like polar coordinates. Now z we can express in terms of x and y. So z is 10 minus 2x minus 5y. So it's 10 minus u times 2 cosine v minus 5 sine v. Okay.
All right, let's see.
So now we have our parametric description of the surface. So now we can use this formula. So we got to compute RU and RV first. Okay, so RU, we got to differentiate all of these with respect to u. So we're going to get cosine v, sine v, 10 minus 2 cosine, oh, no, minus 2 cosine v plus 5 sine v. Okay, so that's RU. RV, we're going to get...
Do you know that you have minus 5 sine v?
Okay, I pulled the minus out.
All right,
Yeah.
I see it.
Yeah.
Yeah. I was listening to you say minus.
Oh, okay.
And yeah.
Point.
No. U cosine v, and then now we differentiate this with respect to v, so we're going to have minus u minus 2 cosine v. Okay, that should be a plus. All right. And then we'll have plus 5 cosine. All right, this is sine. God, I'm making all these mistakes and I'm catching them first. All right. Okay, let's fix up these minuses because it's ugly. All right. Read some notes? Yes. Okay. Now, cross product of that. Yes, it does look a little ugly at first glance. So what we have here is sine v times this. So we're going to have, so RU cross RV. So we're going to have u 2 sine squared v minus 5 cosine v sine v minus the product of these two. Alright. So we're going to have these minuses then become pluses. So plus 2u cosine squared v minus 5u cosine v sine v. So that's one component. I'm going to distribute the u through this part. Okay. Now, can we simplify that? Right.
Yes.
Which one thing it isn't fully working out. Okay. Oh, this is a plus. All right. All right. What can we simplify?
Sine squared and cosine squared.
Yeah. So these combine to make 2u because you have sine squared here, cosine squared here. What else? Yeah, we have 5u cosine v sine v. Here we have plus 5u cosine v sine v. Gone, gone. So the first component is just 2u. All right. Now, if you then compute the second component of a cross product, the exact same thing happens and you get 5u. The third component, you're going to get u cosine squared v plus u sine squared v, same simplification, and you get u. So even though the vectors of partial derivatives has some complexity to them, the cross product did not. So now the area is going to be the integral from 0 to 3 in u, and then 0 to 2 pi in v, and we got to take the magnitude of this thing. So what we're going to get is u times the square root of 30, because when you have square root of 2 squared plus 5 squared plus 1 squared, you're going to get square root of 30 du dv. So this integral, for a change, nothing to it. So you get 9 pi square root of 30 for the area of the surface. Okay. So, alright, so the magnitude of RU cross RV, for completeness, so it's 2u squared plus 5u squared plus u squared square root. Now, strictly speaking, we get absolute value of u times the square root of 30, because the square root of u squared is absolute value of u. But u runs between 0 and 3, so it's okay in this case to just put u.
So the little squares in your notes,
Yeah.
that just signifies the end of an example?
Yes.
Okay.
It's the I'm done square.
What?
For proofs, the I'm done square.
Exactly. Yeah.
Oh, really?
Yes.
It's like all the other symbols, like the
I wish I read through.
the E and stuff like that.
You don't.
Or R.
All right. Now, now here's another example where a surface is defined a little differently. Instead of defining it by a parametric equations, we have this described as being a graph of function. Any questions about this example?